And also, we would also appreciate if you can also help us to share the link through your status or to your respective groups for others to join. And this is also streamed live by our Geotech for YouTube channel. Those who would want to check it out later on. So the recordings are going to be found on our on our on our YouTube channel, and it's live. So the next 1 minute, we're going to kick off irrespective of our numbers, while the rest are going to join us since it's going to be recorded. They're going to join us later on or check our YouTube page for the recordings of the webinar. Okay, without wasting much time, I'm going to use this medium to kick off our webinar. Some of them are going to join us via YouTube, and others are going to join us directly here. And by the way, I'm going to start with an introduction. My name is Jeremiah Oladipo, and I'm a geoscientist and currently work with Geotech for All, which are the ones sponsoring and today's webinar. So I'm going to just do a brief introductions of Geotech for All before we dive into what we're going to do here. This for these few moments I want to spend together. Please, if my voice is audible, can someone just unmute so that I can hear or you also? Just unmute yourself and say something before I kick in. Hello. Can anyone just unmute themselves? So can you just unmute yourself and then just say something?
Okay, thank you, Jeremiah. Everything is working smoothly from my side.
Okay, yes. Thank you very much for that response. And then just say something.
Okay, thank you, Jeremiah. Everything.
Okay, so this webinar is sponsored by Geotech for All, and then Geotech for All is a geodata acquisition, analysis, and visualization firm, and we're actually into geodata analysis, visualization, and we leverage cutting-edge technology and expert knowledge to deliver high-quality geoscience solution. And we are actually looking at the visions of becoming a burgeoning geoscience conglomerate that operate across different ecosystems, across the geoscience spectrums, because we understand how wide. And so we work with the mantra, everything geoscience. So we're working from the feed to the to the text, to the analysis, to the visualizations, and also to the report. So we also handle research in geoscience. We're going to be releasing some of our research output very soon because we're trying to scale them up for the public for public access. And we're going to get to know more about Geotech 4. And so this is one of our first release to the general public about our visions and what we want to do to contribute to geoscience community, not just in Nigeria, but across the world, with contributing intellectually and in every ramifications as it's required of us to do. So today webinar it's going to be focused on GraviMag, and GraviMag is our flagship software contributions to the geoscience community, because we want to try to bridge the gap between the industry and the academia. We understand that the academia also they work with data. Geoscience basically work with data. Geoscience basically work with data, and for these data, depend on this current situation we are having to handle so many data. So how do we analyze those data and visualize them for, ace our communications of the informations that are embedded in those data? And so GraviMag is one of our flagship software, and the idea came up when we're in a training session that was I think 3 years ago now. That's 2 to 3 years ago now, and we actually been trained by someone, that a resource person from the Nigerian Geological Survey Agency, on different data acquisition method, feed data acquisition method. That's in the University of Ibadan. And then we got to the gravity aspect, and basically what we had to do was to use a lot of spreadsheets. We had to use spreadsheets, and then you have to compute for different corrections, mostly for the gravity. You have series of corrections you have to compute for, and then you have to come up with your anomaly, maps, because which is the most important of it. But we understand that the informations that are embedded in those data are not just within the anomaly itself, especially for the research environment. There are other, processings that can be visualized that also help to communicate. And then when you tie all of these informations together, you can come up with a comprehensive kind of presentations of your results. And so that's what we're going to be showing today, our latest software. And our goal is actually to empower geoscientists with tools, computational tools, that helps them to analyze the data and visualize it, in the most seamless, ways that is required, and also not just seamless, but scientifically, acceptable, within the science community. So as you can see my screen, this is the home page of the GraviMag, and it says the features everything you need from raw feed data to publication ready results. So basically, it's to process mostly ground and magnetic processing data, ground and magnetic data acquired on the ground. But I think just a week back, we tried processing it using, some airborne gravity data, because I know I was the one that worked on that, but then we've not finalized it. But those are the subsequent features that are going to be integrated, because we know for airborne, you have a lot of data on the ground on, and so you collect them in grids. And how do we integrate these grids together to come up with the 2D maps, spatial maps, which are going to be integrated anytime soon on the app? They're going to be notified subsequently, and so very important. So you have your coordinate of those stations points that are acquired, so you can also see your station. We're going to get to see all of these with our sample data we're going to use. Or also we have the advanced processing. You have the advanced interpretation, where you have your Euler, the convolution, the power spectrums, regional residual separation, derivative computation for those who are very grounded in geophysics and physics, get to know the implications of all of these interpretations. And also for data import, the primary for the ones we do now, it accept now they're basically CSV formats. We're still working to permit access for XYZ and the other formats that are listed in, but they're going to be done. And also in the web app, you are permitted to collaborate as a team. You can collaborate as a team. You can collaborate as a team, whereby if you sign up as a company or as an institution, and then right from the feed, you can add in users and then see exactly what's going on. And one thing we are sure while using our web app is you have enterprise security. Your data are secure. They are not even accessible by us at the back end. So you can check that up in our review policy, our privacy policy, and see how we handle your data and how secure and encrypted those data are. So how does it work? How does GraviMag work? So we just from upload to insight in 3 steps. I think for those users who have used Oasis, which is one of the major geophysical processing software, you have to load in your grids, your import your Excel format, and then depending on how the data are being acquired, so you can visualize it. But this is quite a little bit different, whereby you import your data in terms of your Excel format, which I'm going to show you once we're done with this introduction. So you upload your survey, you process it, and then you can process and visualize, and then you can share. You can also share and export your data as in PDF format for reports, especially for those who need it for presenting a comprehensive result. And one benefit of this is we made it free academic access for universities, because we know that the research grant, and we're doing this because we have a long time vision to partner with Nigerian universities, just science departments specifically, to ensure that all of these workflows are linked, and so we're connecting. It's our connects both the industry and the academia, such that the student can be industry ready for the geoscience there. And so made it easily. You can easily sign up with your academic email, so it's going to be verified automatically. And then you can start, if when you teach in the class with it, you can teach in the class with it when you do a manual computation. Because I know when I was running my MSc, one of the MSc class, we had to process gravity data and we had to do it manually. You tabulate on your sheets, and write your corrections, and then go and plot later on. So if once you can complement this with those manual, theoretical approach, whereby okay, this is what has been done in the class. How about once it comes to the industry, because the industry wants redirect output, and that's why we make this free access um for the academia. So although this is not going to be free for a long for a lot of for mostly complaints, it's not going to be free, because we're going to be expanding our features anytime from now, because we're gradually integrating those. When we test at the back, we roll it out for the public to use once we're satisfied with it, because that's the way research works. And then we can see how it goes on. But for now, the public beta access, which is what everybody have access to now, for free, and test out and see what you can get from it. So we're not going to waste much time. We just go into what's the interface look like. Like for those who haven't signed up, you can just sign up using the sign in link. Well, I've actually signed in already. Let me sign out back. I'm going to sign out back, and so it's easier for you to sign up using the sign in interface. So it's either you sign up. It's most advisable to sign up with your Google, because Google Access is quite seamless. It's easy, seamless. So just sign up with your Google Access. You're going to receive a verification mail from Geotech, from GraviMag Cloud, and so you can just verify. So once you verify, you're going to be given access into the dashboard. It's a simple dashboard, not too complex for now, right? For now. So let me just sign it. And so for those who haven't, that's for those who have already signed up already. So to sign up, you can sign up as an individual using your Google, or as an institution. So ensure that once you're signing up as an institution, you're using your .edu email, because it's going to verify that for you automatically. So sometimes you might not see all you invest, but we have a way back end in which we're going to communicate to the intending signing user. And in case there's an issue with signing in or signing up, you can always reach out to us by email or on our WhatsApp, which we're going to show you, we're going to release to you at the end of the webinar. So let me just sign into the interface. Let's see what the interface look like. Let's see what the interface look like. And so this is the simple interface of GraviMag Cloud. So you have different options. You have your project, like I'm using, because I'm a super admin. So I'm using the Geotech for All workspace, which is a personal workspace. And you can check your dashboard, your profile settings. You can add your logo to personalize it, and then check, make your. And so if you sign up as an organization, you're going to see this organization option. You're going to get to see the organization option in your profile drop down. And well, for not everyone, it's just where back end that you're going to get to see the admin panel, which is what we use to check all activities. So let's just see, for those who sign up as an organization, you have your member in which you can invite using, once you have the email of the individual, you can invite the individual to, and then give them a specific role. Do you want them to view, to be a viewer only, to edit, or to give admin members privilege? So you can select those options and then invite them. But there's a mail or a link you can copy to send to them, and then they'll access the project that you are actually working on. And so you can check for your invites, and also check for settings to set up your organization profile. And you can also monitor your audit log in case anybody make a change in the project. You can check who made the changes, and follow up in case there's a mix up somewhere. So back to our dashboard. Let's get back to our dashboard. Typically, I have a magnetic project already created, but we're going to start with a new project. We're going to try to see how the gravity is processed using um, using the GraviMag Cloud. We're going to also look at the data formats that permit import. So let's start with a new project. Start with a new project. It's going to load the interface. And so you have the two options. Do you want to process gravity, or do you want to process, magnetic information? So just give me some seconds. Let me sort this out, because we're trying to stream, and so it's giving me some just to increase the stream rate. Okay, so let's just get back. I'll fix that later on. Fix back it down. So please, if you are with me, can you just signify so that we continue? All right, thank you very much for that. And so this is the interface of the GraviMag Cloud. So you have different options. Are you processing gravity, or are you processing using the magnetic data? So it's going to request that you upload your data. So upload your magnetic data sheets, Excel or CSV. So that's the acceptable format. And if you don't know how to format your data, because every software has a format at which they follow, because it's just to ensure that there's a seamless workflow as to how the web app, receive the data and try to process it within the framework that has been created. So you can download the templates. There's a template options here that you can download. You can download the template option just using this template here. So let's see. You can download your gravity template in Excel. There's a way where we want you to format it if you're using the normal Excel format, or in the CSV format. So magnetic also template, and the magnetic template both in Excel and in CSV format. And also you can also read our formatting guide. So formatting guide, you can check it out and see exactly how those formats work. So you can just check and see the formatting guide. This is the formatting guide here. So you can check it out and see how those the data are actually arranged in terms of a table and what data type are required for you to be used in that aspect. So let's just go back. And so let's just look at how data are being formatted. I'm going to open a sample data for you to see. I'm going to open a sample data so you can see both for gravity and for gravity and for magnetic. I'm coming. Okay, this live demonstration. This sorry, it's loading up. I'm going to get to see it in a jiffy. Let me share my screen so you can see it. Just share my entire screen. Okay, please just confirm if you can get to see my screen. Oh, all right. So let's just go. So can you get to see my screen now? Please, if you can see it, just let me know. Hello. All right. Is that a signal? So you can see it. Okay. Thank you very much. Thank you very much for that. So if you can see my screen now, you're going to see the data arrangement formats. For our gravity data, for those have um, who have actually worked with gravity data on the feed on how it's been acquired. They're acquired in loops, open loops and closed loop, whereby you use a base station as your start point, and then you collect points in between all of those stations. So basically, what you need is your dates. Like for those who are using um, the gravimeter, the Lacoste, or any other equipment that are available for gravity data acquisition. So you have your station, your dates when the data is acquired, your station, station descriptions, your latitude, your longitude, your height, if you collect your height, your gravity readings, and your time when it's being collected, and then the remarks. So these are very important because the systems read these information and try to process it based on this format. And so once you have your data arranged in this format, your closed loop and your open loop, yeah, then it's actually ready for import. So just download the templates and then format the data using the template guide to make it a lot easier for you to use. A lot easier for you to use. And also for the magnetic data, it's have a similar format also, but now this you're collecting different information. So you have your distance, you have your average nanotesla, you also have your drift factor, you have your drift itself, you have your regional, you have your reduced data, and you have your reduced value. And so these are how data is going to be, required for it to be formatted so that you can actually import it and then process and visualize it using GraviMag Cloud software. Let's just get back to this. Let me stop this. This is all right. So I'm just going to go back to my tab, share this instead. So let's just see how do we import that data and then visualize it with GraviMag Cloud? So you can just you can either import it manually by adding your station, but it's more advisable for those who, because of the feed will be rugged, so you just have to just collect it more in a Excel, arrange it properly, and then so you can import it. That's for those. But if you are working directly, because we're also making we want to make this also to be easily used on the feed. So that's why we're adding these features. But then we're going to complete the whole process so that you can have a mobile access view, so that on the feed directly you can also have it handy to you. So if you have your data arranged, you can select import. You choose your file. You go to choose your file. Go to find where my file is. I'm going to get that. And then this is what I'm going to use, Gravity Data Live Demonstration, and open. So it says imported 37 stations from CSV file. So automatically it brings that data file and then, tries to, as compute out all the data. And so you can look at the data table. You can see your station, your serial number, your station latitude, your longitude, your height, your gravity reading, your raw gravity, drift corrections, final observed, and then these are the corrections that are applied to it. All of these are corrections. All of these are corrections applied, automatically processed and applied by GraviMag Cloud. So this is a whole lot. You can just see done within just a single click of your process button. And so there are some parameters that have to be set. If you have your density information and also your known absolute value, depending on the region, because we know um, the absolute value might change across regions depending on where you're talking about. This one that was used is basically the one used in Nigeria by the NJC, which was one of the data we used. And so this was what we use as the absolute value. So you get if you have your absolute value, put your absolute value there so that it's going to affect the values, how they're going to be subtracted. If you notice our absolute value, these are the values here. And so it's also part of the computational process to subtract your raw from your absolute value to get your um, both your free air and also the absolute gravity later on. And so once you're done with that and you want to visualize, you can click on the charts. There's a charts there's a charts icon here. So data is actually being visualized using the charts. You can see the charts. Can you see the charts? Hello, can anybody hear me?
Yes.
Yeah, so you can see how the chart pops out, taking those data. So your chart is a chart of your free air and then Bouguer anomaly profiles. And so you have your anomaly on your vertical and then your free, so you're going to have and the station number on the horizontal, on the horizontal axis. That's based on the computation that has been made originally. And so that's for the free air, which is the major charts. So you can also check, that's for your anomaly profiles under your chart. You can compare your free air and Bouguer together. You can see. So your free air is at the reds, your Bouguer are the blue. So you can see, you compare how they vary across themselves. And basically the chart is based on the data that was imported. So which the accuracy of basically all we do in geoscience or any scientific endeavor, is a functions of how um, adequate. I'm not going to use the word accurate. The data are acquired because accuracy is kind of relative. So how adequate data is, how it fits into the picture of what you're trying to look for. And so you can visualize it. This is just the free air. Also, you have other corrections. You have other corrections for year applied per stations. We can't see any information just because um, I'm going to explain this now. Okay, I'm going to explain later why this isn't popping up, so you can see it. Also, you have your elevation profile. So we didn't have any elevation information in our Excel spreadsheet, and that's why um, our correction didn't work. And yes, that's also for this for each station. You have your free air. You're supposed to plot. It's supposed to plot the information data of your free air subtracted from your elevations to get this. But since there's no elevation, this can actually be shown. So these are basically the charts that we make, you know, available in this first phase. And this is mostly applied once you are interpreting based on traverse. I'm going to try to explain why we've now integrated, the 2D, spatial map in this aspect, because it involves interpolation. You have to have series of, profiles, stacked across themselves to be able to come up with that, which we're trying to do, and we're going to release it out very soon. So you can also check your data to confirm, because we want to confirm our data if they fall within the area that are required. So you can check your station maps and look at how your profiles actually, you know, how your stations, the data are collected on the feed, how they are collected on the feed. So you have for the reds here, you have your base stations, which is the first one. So you have your closed loop, your open loop. So we differentiate them using different colors. And you can see these are just collected along a straight profile. And so for us we're going to integrate the 2D very soon, whereby imagine you have, one traverse like this, you have another one upside down, we have another one upside down. We're going to see the other features. We're going to notify everybody who signed up for the GraviMag Cloud when those features are live. But this is just for individual profiles, and you can interpret based on the individual traverses. And later on, they're going to be integrated. So you can just confirm your work. You can zoom in to confirm, okay, what area does this data fall into? So you can just check. This is in Nigeria, around between that's Adamawa's. Sorry, that's Potiskum. Potiskum somewhere in Maiduguri side of Nigeria. Yobe, Damaturu, all those areas. So the data, that was where this data was acquired from. So let's check other features that are here. We have an interpretation panel. So for the interpretation panel, let's see what comes out. So for the interpretation panel, we have the regional to residual separation. These are a little bit of advanced interpretation for the scientific people among us who want to use this to write papers. So we have to integrate this. So you have different chart for that. Your Bouguer anomaly, compared to the regional residual separations. You can see how you can also try to, increase the degree and compare later on. By the end of this webinar, I'm going to release the computational engine document, which I'm going to also show you once we are done with this walkthrough. So you can just increase to visualize and see, how your data varies, and then you make your interpretation. And please, this is not an interpretation webinar. This is just a walkthrough of how the data are being processed and visualized. So you also have the derivative filters and edge detection. That's for those who are for this derivative, that for those who are basically looking for these for edge detection. That's where you can find our features, geologic features like fractures, faults, lineaments, and so where you kind of find those deviation from the normal. You also have the analytics signal amplitude. So for these edge filters, we have the horizontal gradient, the vertical gradient, and the analytic signal amplitude. And for depth analysis, we have the power spectrum. You can visualize your power spectrum based on the individual profiles. You can compare. You can also compare with your free air depth corrections to see. So it also is going to give you an estimate of the depth source and we also have the upward and downward continuation charts in which it's being visualized. So you can see how everything the Euler, the convolution 2D. This you can, depending on what you want to model. So no valid Euler. So depending on what you want to model, you check and select which ones are. Is it free air you're looking for? Is it dike? So if they are available, you can increase your number of stations. You can reduce it to check if you can get more stations. So for Windows, 5 stations, you can see different depth popping up. So it's going to compute those things for you. And please usually advise that this is in the build phase. We ensure you confirm your attribute and verify it with other standards so that we can be on the same page also. So that's just on the interpretation aspect for those who want to, come up with a research paper using the data. And let's check the corrections tab. We have advanced corrections. We have for the terrain, for the tidal, for the isostatic, also. So you can check and see, the values that are corrected, how they are being applied across all of these stations, So you can scroll through to check for the tidal also. For the tidal, you check and confirm. And so for the isostatic, you check and confirm your information. And most importantly, we had to integrate a survey QC quality check of our data. So you can confirm if in case your data didn't import correctly, like for this, we had 37 stations. So 3 loops, which is correct. We had 3 loops. And you can confirm that from your base station. From your base station, you have loop 1. This is loop 1. This is loop 2. And this is loop 3. And this is loop 3. So you can, you know that yes, it's confirmed. And then you check this. So there's also our main closure. Is it good? Is it excellent? So it's showing us that it's quite a little bit poor. It's quite a little bit poor. That's just from the statistical analysis that was made on the data. So for poor, it exceeds our fair threshold. For fair, once the drift is less than 1.5 and the closure is less than 0.1 milligal, it tells us that it's quite good on that. And so loop by loop statistics, you can also see that down here. So that's just basically on the gravity aspect. So for you visualizing your from your data table to your charts, to your station maps, to your interpretations, and so on. And the most important thing is that you have the ability to save your work. So there's the options to save. There's the option for you to save. You can save to the cloud, which is why we call it GraviMag Cloud, whereby you can save your work to the cloud, because we understand that majority of our geoscientific processings, our data are kept in silos. And so you find it very difficult. I've been working with quite a lot of people, and I think there's a project we're still currently running, and then we acquired a lot of data, and we have to see how do we keep it within a system that makes it easy for us to query and access. For this, that's what we try to do with GraviMag Cloud, so that your data are kept in the cloud, and then you can access it. You can just save it. You can save your work. You can save your work, and then later on, say project gravity survey save to cloud. So you can save it. You can also export your data as it is. You have the option to export, and you can also export the full report of all of this data, all of this processing that was done. So let's export and let's check what the report is all about. Let's see what the report is all about. Just going to take some minutes. Let me share. Let me change the share screen to that. I'm going to share the screen to there. All right. So can you confirm if you can see my screen? All right, yes. So this is the sample of the report that is being generated. And so you can check through to see also, you can check through to see, all those computation that was done in case you need it in your report. You have the statistical summary of your free air, your Bouguer, your absolute, your drift. You have the statistical table there that has been exported. You have your processed gravity data, the one you see on that first page, when you can see how they have been processed. The computations are there, which you can extract it to use in your research paper or your report, technical report as required. So your interpretation report is also exported. You have your derivative analysis, how the data are computed, what values are being used to come up with those charts, and how they, so you can see them. You can see all of this, your power spectrum analysis, where you estimate depth. It estimates the depth for you. So, and tells you what is being used to estimate that depth. And we have the gravity reduction. So this is just for the formula being used within the software. So this is just the sample report. But so for your charts, I know you'll be asking, can we also export the chart? Yes, you can export your charts. Let's go back. So you can export your charts directly from, let's go back here. You can export the charts. You can export the chart directly by using this download icon. Can you see the download icon?
Yes.
Can you see? Yeah, so you can export the chart. Once you press download, you can either download in PNG and SVG, any of those options. So you can download all of the charts. You can even come back here. I think we have an option for batch export. Let me go back. Okay. Okay, no, for now we've not activated that. So you can check. Let's check our outputs. Let's see how the chart looks like. Coming. Let's just download this. So I'm not sure you can see it now. Let me share the screen to that so that you can see it. Okay, yeah, so window. Okay, so once you download your chat, you can as well, see it. Can you see my screen now? So this is just the export. So it exports the same way, it's being visualized, and so you can use it in any of your work as to back up your interpretations in that aspect. And so for all of the charts within those within the web app, you can actually do that to it. You can export them. So we didn't add it as part of the exports because it depends on which of the charts you require for your work, which is most important for your work. So this is just for the gravity aspects, and we're going to just take a little pause before we go to the magnetic aspects. Maybe I'm going to just take in just maybe one or two questions on the gravity aspect before we also do a walkthrough of the magnetic, and we call it, a day. So any question, and we might not be able to answer every other question now because we know we're trying to work with feedback from users, and that's why we're doing this so that we can expand later on and make it more, of a good use to the general geoscience community. So if you have any question, you can just unmute yourself and ask. And even though you don't have now, you can also always reach out to us via WhatsApp or via our email, support@geotechforall.com, to get to know more. And in case you have any challenges, you can reach out to us. So any question before I move ahead with the magnetic? All right. In the absence of that, let's just take some step ahead. So the magnetic is also similar to the gravity, but we're trying to, but it's based on different data as I've shown you in the data format setting. And for the magnetic, we will ensure that your data are in Excel and CSV format. This for ground magnetic data. We've not integrated for the grid for those one that data are actually acquired in end user. But there's a way for those who are software geeks are amongst us. There's a way you can convert your grid data to XYZ or into an Excel formatted data. But if you acquire data from the feed, so you ensure that your data are formatted, using the sample template, the template that was provided, and so you can easily import it. So let's just import. Let's choose a file. We're going to choose a file, and so I'm going to use this magnetic sample one. Click OK. So it's telling us that imported 209 magnetic stations from CSV. 209 stations has been imported, and so you can see all of those informations here. So remember, the data required is just the serial, the distance, the average nanotesla, the time, drift factor, drift regional with this data. And so it computes all this. These are the computed ones. The reduced value, the diurnal corrections, the total anomaly, are automatically computed. So you can see all of that for all the host station, the processed data. You can see it for all the stations. And so once they have been processed, and it also has some parameters, your drift factor, your regional feed. If you have the informations, you ensure you input them, because these are going to be used. They're going to affect. Imagine if we were using the international georeference regional feed. So it's automatically going to compute that for us and say, let's say, assume you reprocess this data. So it's going to recompute all of those for you if you are using the IGRF regional feed data. But if you have your own data, you input it, and then you reprocess the data, and then you get your output. So what charts are being provided? You have the magnetic anomaly profile, which is the most important, actually. So this is the charts. So it visualizes data. You can easily identify where those anomalies are, either positive, magnetic, or where those drops in those zones are. You can check them. You check the values. This is a 0 point, and so this is a negative. So downwards is a negative zone. So they're giving us a negative anomaly around there. So you also have your total feed, which is another one. You can see your total feed charts, and then your corrections. What are the applied corrections? Your drift and the diurnal. Those are just the major ones done the magnetic for now. We haven't really done much in the magnetics, because we are trying to take it one phase at the other into the cloud. And so you can also view your station. If you add informations of your stations, your coordinate informations, they're going to be visualized also. But for this data I process, they are not coordinate added to the file, and so you don't have to, it's not going to view it. And you can also check the advanced. So there are some advanced charts, like your reductions to pole, your reduction to pole charts, your derivative filters and analytical signal, and your power spectrum for depth analysis, your upward continuation, to bring more clarity to the features, how they are being seen. Also, your Euler deconvolution charts, you can check the variations in this data. You can also check and compute on those processes. You can select and see, are you modeling for a fair, or a contact, so it's going to tell you. So say try adjusting. So depending on what you're modeling for, you can select your window, maybe 10 or 15, depending how many windows you want to use. So this is just the simpler aspect of the magnetic, not so much for has been done for now. And also you can save your work. You can just save it magnetic, give it your magnetic live demonstration. Let me take a live demonstration. And then you can save your work. So it's going to save to the cloud. So project magnetic live demonstration save to cloud. And you can also export your report. Let's export and let's see. Let's see what we've got. Let's see what we've got also in the exports. Just go back here and change this. Go back to window. So magnetic there. So can you get this to my screen now? All right. So for the magnetic, you can see data has been exported. You can also, scroll down. So it also has a statistical summary. The process similar to just the gravity data that was being exported for all your stations. You can see the corrections that have been made, the raw data, and then your advanced interpretation, report, the data that have been computed. And why we started from this is for those who use Oasis, sometimes it feels that Oasis perform, magic most times, but it doesn't perform magic. Oasis also starts from all of these bases, And so it's just the fact that it works more as a 2D map. So it tries to apply colors to them. So what it does is once your data are acquired in profiles, which are stacked along themselves, it computes all of these values and then try to interpolate to come up with those, and then visualize the variations of the contours across those areas based on the data distribution, and use colors to what for the to permit a visual interpretation, qualitative interpretation, both qualitative and semi-quantitative interpretations of your work. So that's what Oasis works on, and we're getting there gradually. So with this, because this is the foundation, and then we just to add other ones on it. So you can check all of these your data and then make use of it for your interpretations and your write-ups. That yes, this is how it works, and then just so on. And the same way you export your charts, you can also do that right, on the chart icon. You can export that on the chart icon. And let's check through. Let me see what next on our list. So back to so that's for the gravity itself. So we've checked the gravity, we've checked the magnetic, how it works, how the export also works, and you can also look at your summary of your information and datas, and then export out very required. And for your work that are saved, you can go back to the dashboard. You can go back to your dashboard and then check your work. So whenever you log in, you log out, you can see your data has been saved. So we have magnetic, we have a magnetic, and then we have your actually I did gravity. I think it did. So you can also come back, check your work. You see it's been saved there anytime, any day that you need to check it out. And you can also share. There's an option to share your work. You can click the share. Just they're going to be notified within the and then select what user do you want it to be, editor or viewer. You can share your project. So that's basically how it works for the GraviMag Cloud. It's quite simple and direct. Just make sure you format your data in the required acceptable format, import it, and then you visualize and then process your data. But ensure that the quality of your data is most important. Everything the software does, it works with us the data you feed in. So what you feed in, determines what gets outside of it. And like I said, that the computational engine behind it, because for the academic people, uh, academic individuals among us, we always need the engine behind what we use. They're basically the same standard being used in the industry. Let me just share. Let me just share the PDF to see. Okay, so we have our data formatting guide here. I'm coming. Okay, this is not it. Okay, that's not it. That's not the engine. I'm coming. We've made a summary of that, and then okay, just give me some minutes. All right, so we have the PDF. Once we're done with the webinar, we're going to share it across to every user who came to the webinar. So you can check, you can see the engine, and then use it in your work for the formulas, especially when you're working on your methodology. For those who would love to use it, so it has been summarized, and it's going to be updated once we add up other features to it, other processing engine to it, and in case there's a new recent processing techniques that has been added, they're all going to be updated later on. You can also download this directly. You can download this directly rather than waiting for us to send it to you. You can check. You can check the website has been integrated on the website. Let me share my screen so you can see it where you can download it on the website. You can get to see it on the website screen. Let me just go back like this. Landing. Right, sorry, that's the wrong link. So when you get to the landing page, you're going to get to see it just down here. So you can download the document immediately down here to check it and use it for the required purpose as is required of you. So you can easily download it right on the link from the website to check it out in that aspect. And so that's basically what we're presenting today for our live demonstrations. We're going to be releasing subsequent, short videos on our social media page and YouTube channel. That's at geotechforall.com. So I'm going to encourage that you follow us because this is just the first, and we have a very big announcement coming up on Monday because we have a free tool we're going to be releasing out to the general public. This is not going to be completely free, but the one we're releasing out is going to be free. And just follow us on our LinkedIn, Twitter, Facebook, Instagram. So we have a very big announcement on Monday. I'm going to keep that. Um, I'm going to keep that information till then. So once you see it, it's going to be a free tool you can access and can use for your work. And we will also love to partner for those who are lecturers amongst us. We would love to partner with you. You can also reach out to us by mail because we are readily available to work with you and your students because we know there's a lot of gap between the industry and academia in the country, and not just in the country, but in the audio science industry. We want to see with the little we are working on can go a long way to stimulate and spice up our academics in the long run. And we're going to really appreciate if you get to reach out to us, and so we can know when to schedule you know sessions with you, not just for this GraviMag. We have other softwares we're working on within the team, which the informations are going to be released out to the public once we get to those stages. And also we're going to appreciate um, review from you. We really appreciate those who have signed up already and who have tried testing it out. In case you want to test it out, you can reach out to me. We can give you sample data that we have within that you can use to test within your site. And in case you want to process in your own aspect and you have those data and then you're finding difficult, you can also reach out to us. We have teams, we have people on ground that are going to respond and be willing to help out to help you, get used to these tools. You understand that we are in a fast-moving, destructive period whereby new technology are taking the grounds, they're taking the grounds, and so you need to plug in as early as possible so that you can get to integrate all of these workflows in your work and in your project, and it makes it really brilliant and intuitive enough when they get to see them out there. And we're going to appreciate a lot of review from you. You can drop a review. Okay, yeah. So thank you. So you can just drop a review for us. For those who have checked it out, we're going to really appreciate that constructive review and other features you want to see. But we also appreciate if you can test it out and see what it offers for you. And I'm going to pause here. I'm going to open the floor to everyone because I really appreciate you for taking it. We've almost spent an hour already, more than an hour already. And want to hear from you, taking out your time to spend this aspect with us to see what we have for you. So I'm going to open the floor to those who joined us for questions before we move ahead. Please, any question? Any question?
Okay, thank you for our presentation or demonstration from Abakar Mounde. Okay. Are you hearing me?
Yes, I can hear you clearly.
Okay, thank you for that. Abakar Mounde from Modibo Adama University of Technology, Yola, Adamawa State. Yeah, if I really get you for now, we are going to just input a kind of line data, not grid data. That is the profile
Ye-
data for the starting.
yes, yes, basically. So what this first public access gives you is that you it's preferable you interpret just by profile, your profile,
Oh,
individual profiles. So
lovely.
you
That's
are
good.
trying to interpret individual profiles. But subsequently, but working on bringing in the grids, because when you bring in grids, they're quite larger. And so
Yeah,
because
yeah, yeah.
we're trying to move from just standalone on your local laptop to the cloud, it takes us to create some streamlined workflow for
Okay,
those
that's good.
to be very adequate. But for this first phase that we release out, you interpret based on your profiles, your individual profiles, and you
Okay.
can stack them all together. But
Oh,
subsequently, once we integrate the grid processing, it will be notified on that.
okay, that's good. Thank you for that.
Yes, thank you very much. Any other question?
All right. Good afternoon, everyone.
Yes, good afternoon.
This is Elvis from Federal University of Petroleum Resources in Delta. Thank you so much for the presentation. I just want to ask, because it was very insightful and clear enough, but I want to ask, can this also be used for processing and interpretation of observatory data, both gravity and magnetics?
Yes, it can. I want to understand what observatory data is that. Because I need to understand what observatory data is that.
Yeah, instead of going to the field for your magnetic and gravity survey, you have observatories, geomagnetic observatories and gravity observatories that collect gravity and magnetic data all day long. But though we don't have
Yeah,
any observatory in Nigeria, but we have in other countries of the world. So, and there are some of these observatory data that we use for doing some geomagnetic interpretation, and also like you have satellite, magnetic satellite data.
yes.
So I'm talking
Yes,
about
you
those
can.
kind of
You
data.
can actually. Yes, you can actually use that. Like for the gravity sample I used, I actually
Yeah.
used an observatory data to do that. But what I did was I actually said it earlier that you have to format the observatory data because the observatory data may not be collected. When you download it for that specific area. Let's take for
Yeah,
example, when you download the observatory data for that area, you have quite a lot of data. So
of
the
course.
first thing I usually advise is you plot the coordinate point on your maps and try to
Okay.
break them into profiles. You're going to see them arranged. There's a way I
Mm.
did it for this before this webinar. I did it for this. The data I used was an observatory data I downloaded, but I had to reformat it into profiles.
Okay.
So I break them into, okay, if I'm taking this profile from year to this year, maybe within those the boundary range I'm looking at, I'll make it as a open close for that. That's if for gravity. I'll use one
Okay.
as an open, the first point, the last point as a close, and then the second data will form another profile for me beneath it or maybe above it, depending on how the data is connected, maybe north to south or southward. So you're going to break it down. Let me show you. Let me just try to see if I can make a example of what I'm talking about. Coming, let me look for the read data I downloaded. I'm going to show you now. All right, so coming. Okay, yes, I think I've seen it. I think I've seen it. So I have this data for Adamawa states. Like the data we used was observation data for that Adamawa state. Let me share my screen. I'm going to share my screen now. So Windows, so Adamawa state. And so I collected this data from satellite imagery. And so I have it downloaded in the XY and the our Z is our gravity data. Can you see my screen?
Yeah, I can. I can. Yeah.
And so because this data covers the whole of Adamawa state, like the
Okay.
whole of Adamawa state. And so what I had to do at first is to plot them. Let me show you. Let me import it into the GraviMag Cloud. You can also import it directly, actually, like this. You
Like
can
this.
import it not directly, like you have to reformat it.
Okay.
Let me show you the one I reformatted into. I had to reformat it into a different format. Coming. So, okay, so that same data that was, I'm going to try to box my screen together. Okay. Now, this is coming almost there so that you can see it clearly. So this is the data that was downloaded for Adamawa State altogether. But you know, this is not the format, the template we use on GraviMag. So what I do is I try to reformat it into the format that I need. Let me see. Share screen. And so I try to reformat it into this format. Can you see my screen?
Coming up.
How about now?
Yeah, I can see it now.
And so it's what I try to reformat it using that same format. I just try to just come up with you know, a date and time that was acquired for it, so that so you can see everything clearly. So what you see here, you have your date. I try to just come up with a date, you know, descriptions, and then we know we already have our gravity reading. So I assume I just gave it an height of 0 because the data that was downloaded didn't give us an information of the height. But I think there's some site that gives you an gravity heights anomaly, you know, corrections like that. So there are quite a lot of data, quite a lot. Look at. So when I took all of them as an open and closed loop, let me import this data into GraviMag Cloud and show you to see how it comes up. I'm going to share my screen to GraviMag Cloud so that you can see it. Oh, GraviMag Cloud, yeah. I'm going to import that data. Let me sign in back. And then I want to create a new project. That's Gravity, right? So I'm going to I think it's in my download. So this is the data file I reformatted into it. And then I click open. So it said fail to pass. So it's not in CSV. So that's why. So let's go back. Let's have it in another format. Just gravity data, all right? So just ensure that your data file is in CSV. So you can just confirm from here. Let's select the CSV one. So this command terminated. So I'll click open. And so imported 202 stations. So you can also confirm. Let me check the Z spreadsheet to know if it's 202 stations that are there. Yes, 203 lines. So when you subtract your header, you're going to have 202 stations there. So once you process it, you're going to look at the information. Can you see the screen? Are you seeing the data? Hello, Elvis? Hello? I hope you're still with me. Please, if you can still hear me, kindly let me know before I proceed. Hello, can anybody hear me? Hello, can anyone hear me? Oof. Okay, please, if you can hear me, just kindly let me know so that I'll proceed. So once you process data like that, if you check your station map, you're going to see that the data are okay. This is the other data. Let me load the other ones. I think I loaded not the correct one. So corrected, grammar formatted. Let's see. Failed to pass. Coming. Let me just receive it as CSV so we can import it. I'm going to save as. I'm going to save as CSV. Just that's CSV. So that we can use it directly on the GraviMag Cloud. So I'm going to import. Let me import the correct one. I'm going to go downloads and going to select the CSV. So I want to click open. So 202 stations. So if you check your station map, you notice that there are quite a lot of data here. Quite a lot. When you zoom in, you're going to see how those profiles are quite long. And so imagine you have the first line, you have the second line also, and you also have the third line. Let's assuming that's just 3 profiles. So what I usually do is to break this down. What I did was to break the first line, to take it as to assume it as a single, like a single traverse or profile. So what I did was to assume it as a single traverse or profile. And then once that is being done, I can re-import the data as individual profiles and then continue my work. So I guess that answers your questions. All right. So with this, we're going to come to the very end, and subsequently, we're going to reach out. We just advise that you follow us on our social media platform so that you can get to know more of our offering. And we're saying really thank you very much for joining us. To David, to Elvis, to Mandy Bobo, Elvis from Fupre, to Mr. Abubakar, to David who joined us, and others who joined us by YouTube Live. We really appreciate your presence. We appreciate your presence, and we look forward to seeing you experiment with it and getting to let us know more about your experience with it. Thank you very much, and I wish you a very, very, very great weekend. See you. Thank you.